Amanda used the pH meter first. After removing the probe from storage, she began calibrating it using a 2-point method. She rinsed the tip twice in deionized water and dried the sides of it, making sure not to touch the thin glass membrane at the end. While stirring with the tip of the probe submerged in the buffer solution with a neutral pH of 7, she set the first point of the meter to 7. She then rinsed and dried the probe again. Stirring in the buffer solution with a known pH of 4, she set the second point of the meter to 4. With the probe calibrated to measure the pH of acidic solutions, she could then measure the pH of apple juice. She cleaned the probe and stirred the apple juice, making sure not to bump the sides of the vessel with the probe. Once the meter stabilized, we read and recorded a pH of 3.59. Amanda properly cleaned and stored the probe. Pooja was second to use the pH meter. She calibrated the probe much like Amanda had. She began the calibration by stirring in the buffer solution with a pH of 7. Buffers, like the ones we used, are aqueous solutions with fairly stable pHs. They are commonly made of a large concentration of a weak acid or a weak base and its conjugate base or acid, respectively. If a small amount of acid or base is added to the buffer, its pH resists changing because it will neutralize both. The pH of buffers is also not significantly affected by dilution or the evaporation of water from the solution. After completing the calibration, Pooja took the pH of orange juice, which was 3.51. She properly cleaned and stored the probe. Natalie went third. She calibrated the meter. On a side note, we noticed a difference in the pHs of weak and strong acids throughout this lab. This difference occurred because strong acids dissociate completely in water, contributing many more protons or hydrogen ions than weak acids, which leads to a lower pH. Weak acids do not completely dissociate into ions and remain in solution largely as whole molecules. An equilibrium is established with weak acids as some molecules dissociate and some ions form molecules. The equilibrium constant for weak acids is less than 1, whereas the equilibrium constant for strong acids is close to infinity because the reaction is irreversible. So, after finishing her calibration, Natalie measured the pH of deionized water, which was 5.96. She cleaned and stored the probe. I calibrated using a 2-point method like the other girls had previously done, cleaning and drying the probe between solutions. To complete this part of the lab, I took the pH of tap water, which was 7.21, and recorded the result in my notebook. I cleaned, dried, and stored the probe.